Hi students, today we will discuss about mole concept. So very important topic, this is mole concept. In that, first atomic mass, we have to learn about atomic mass. Atomic mass means atomic mass. Before we should learn about atom. So atom means the term atom was introduced by Dalton. Term atom was introduced by John Dalton. Atom is the smallest particle. Atom is the smallest particle of matter. Atom is the smallest particle of matter that takes part in a chemical reactions. Atom is also defined as the smallest particle of an element that retain all the properties of an element. So which is the smallest particle of matter? That is also atom, or which is retains all the properties of an element? Also atom. So atoms example: hydrogen atom, oxygen atom, and nitrogen atom. Like this is atoms. So now atomic mass. Now our topic, atomic mass. Atomic mass unit, UNIT. Atomic mass unit, also known as AMU. Atomic mass unit. Atomic mass unit. Now we will call that is unified mass U. So the smallest unit of mass and is used to measure the masses of atoms and subatomic particles. AMU means atomic mass unit. AMU means it is a smallest unit of mass and is used to measure the masses of atoms. Are masses atoms and subatomic particles also. What is subatomic particles? Subatomic particles also. Subatomic particle means electron, proton, neutron like masses. Also we will measure like AMU, atomic mass units. That unit is AMU. Mass of one AMU is equal to how much? Mass of one AMU. How much quantity? That mass of one AMU is equal to the masses of the mass of 1/12th, the mass of 1/12th mass of carbon 12 isotopic atom. The other name of AMU atomic mass unit is Dalton, Avogram. Austin Dalton Avogram. Other name of AMU is Austin Dalton Avogram. 1 AMU is equal to how much? Mass of 1 AMU is equal to 1 by 12th part of carbon isotopic atom. That means simply I will say, I will explain like this. This is one carbon atom, means 1 2 3 4 5 6 7 8. Can take like this: 1 2 3 4 5 6 7 8 9 10 11. So one more, 5 6 7 8 9 10 11 12. So in this one part is 1 AMU. Carbon 12 atom, carbon mass is 12 AMU, means in that 1 AMU is equal to how much? 1 by 12th part of carbon isotopic atom. So 1 by 12th part of carbon isotopic atom means 1 AMU equal to 1 part of the carbon atom. 1 part of the carbon atom. How many parts is there? 12 parts is there. So in that 1 part is equal to 1 AMU. This is the meaning of 1 by 12th part of carbon atom, isotopic atom, like. So I think you can clearly understand. Now I have to measure for hydrogen atom mass or helium mass. Like helium mass I want, I don't know how much, but carbon mass I know. Here 12 parts is there. So I want to measure that. Like this is simple balance, like I am taking this side helium atom, I keep in helium in this side. So here I am adding 1 part of carbon, 1 AMU, 1 part of carbon. Next one more part of carbon I am adding, but not equal. Next one more AMU I am adding, also not equal. Next one more AMU I am adding, it is equal. How many AMUs I am adding? 4 AMUs adding. So now helium weight how much? 4 AMU. Like earlier the scientists are measured like that. So one watermelon is there, like one watermelon, they are cut into 12 pieces. In that, this side one piece, this side one brinjal or banana will keep, means it will balanced or not. Like they are thinking like that, they are balancing. Now 4 AMU is equal to helium mass. How many times this is how many times heavier than 1 by 12th part of carbon? How many times heavier? 4 times heavier than 1 AMU. 4 times heavier than 1 AMU. So this is the atomic mass unit calculation. 1 AMU is equal to, in grams, how much? 1 AMU, 1 Avogadro, 1 atomic mass unit is equal to 1.66 into 10 power minus 24 grams. This is equal to, or this is also known as proton mass. Proton mass are also known as 1.66 into 10 power minus 27 kgs. In kgs 27, in grams minus 24 grams. So 1 AMU is equal to, in grams this much, in kgs this much. Now atomic weight. Atomic weight. Atomic weight. Atomic weight means the weight. The atomic weight is defined by total number of atomic weight, defined as total number of protons and total number of neutrons, total number of protons and total number of protons and neutrons in an atom, in an atom is called atomic weight. The mass of proton is nearly equal to the mass of neutron. Mass of proton is nearly equal to mass of neutrons. For example, we will take example one atomic weight, carbon atomic weight we want. So carbon atom having 6 electrons and 6 protons and 6 neutrons, so that only it is a reference element to calculate the masses of all the elements. Okay, 6 electrons, 6 protons, 6 neutrons is there. That means the weight of carbon atom is equal to 12. The atomic weight are related to atomic mass. This is about atomic weight. Now relative atomic weight. Atomic mass have unit, that is AMU. Relative atomic mass have no units. Relative atomic mass means RAM. Relative atomic mass defined as the number of times of an atom, or element, number of times of an atom of an element is heavier than the mass of heavier than the mass of 1/12th part of carbon 12 isotope atom or isotopes. See here, relative means compare. I said no before, one watermelon 12 parts, like a carbon atom is 12 parts. In that one atom helium we want to measure, means compare that. How many times heavier? By 1/12th, 4 times heavier. Same relative atomic mass element, one formula also is there, RAM. Relative atomic mass is equal to mass of one atom of that element by 1/12 into mass of carbon 12 atom. Mass of carbon 12 means 12 only mass. Now apply this one, compare this one. Relative atomic mass we want means we will take one atom of that element, means some other, like calcium atom I am taking. For example, atomic weight of calcium we want, so that atomic weight is 40 by 1/12 into 12 cancel, we will get 40. So this is the atomic weight average. On the average of 40 times of the 1/12th of carbon mass isotope atom is heavier. How many times? 40 times heavier. So this is only relative atomic mass comparison. Already mass we know, 1 by 12 into 12, 12, 12 get cancelled. We will get 40 by 1, that is also 40. So a relative atomic mass have no units, but atomic mass have unit. Relative atomic mass. Next, atomic weight, how they calculated, how we know this is a 40, like this means it is just a comparison only, but how they calculated, I will say one example. Calculation of chlorine. Natural chlorine is a mixture of, every element have isotopes, so that only we have some fractional atomic masses also. Just atomic mass, I said before, number of neutrons and number of protons only, total number of neutrons or protons only mass I said, but it is true or really means how not. Chlorine mass is how much? 35.5 will come. That means any proton or neutron half is there, half proton or half neutron is there? No. Why 0.5 came? So that only now we are discussing. Natural chlorine is a mixture of two isotopes. Every element have isotopes. In that example we are taking chlorine. Isotopes with relative abundance. Relative abundance. 75% of chlorine atoms having 35 mass, and remaining 25% of chlorine atoms having 37 mass, approximately. Now I think you can understand. I am collecting 100 naturally occurring chlorine, 100 atoms I am collecting, 100 atoms of Cl gas, 100 atoms of Cl2 chlorine gas collecting means, in that 100, 75 atoms mass, how much? 35 mass, 35 is there, plus 25 atoms mass, how much is there? 37 is there. So divided by total number of atoms, how much average? 100 atoms, no? Equal to, we will get exactly 35.5. This is the calculated atomic masses of all the elements. So chlorine, natural occurring chlorine we will get. Otherwise, simply in 4 atoms I am collecting means not 100. If 4 atoms means, one more method, 4 atoms I am collecting, 3 atoms mass 35 plus 1 atom mass 37 is there. If total number of atoms is 4, then also we will get 35.5 mass. Fractional atomic masses will come. Reason is isotopes. The average atomic masses of isotopes, all the occurring isotopes, nature generally. Okay, this is the reason for atoms having fractional atomic masses. Total number of, here mass of chlorine is 35 I said. That means that chlorine atomic number 17, mass is 35. One more chlorine also 17, mass is 37. So this means these two what? Isotopes. Isotope definition I will say now. Isotopes. Isotope means same atomic number but different mass number. Different mass number. Mass number is known as isotopes. Example, chlorine 1735, chlorine 1737. In nature, this atoms, how many percentage is there? 70% is there. This one 25% is there. So that means mass 35 means, or 37 means, number of neutrons here difference is there. See, in this 17 protons fix because atomic number only proton. 17 fix. How many neutrons is there? 35 minus 17. Mass number minus atomic number we will do means we will get number of neutrons. How many neutrons now? From this we can remove 17 means 25. In that 5 also removed. That means I will do, okay, 25. Okay, here 35 minus 17, 18 neutrons, 17 protons and 18 neutrons. So total 35 mass. So protons, neutrons difference is there in isotopes. See here in this atom 37 minus 17, how much? 20 neutrons and 17 protons. Total 37. Mass is 37. Number of neutrons and protons only mass. Number of neutrons and protons only mass. So that 37 mass and 35 mass came. But which element mass we have to take for chlorine atom? Mass means 37, 35. So that only scientists they will decided like average atomic mass of naturally occurring elements. So in these two elements average we will take means that one will come 35.5. Now chlorine mass is like 35.5. Okay, thank you. Remaining tomorrow we'll discuss. Thank you.